Good morning. My name is Ben Brady, and I am the 3D Printing Texan. This morning, we're going to jump in here and do a real quick DesignSpark tutorial, or as quick as I can do it. I'm going to give you some details about some features that are in DesignSpark that aren't typically covered in any of the DesignSpark tutorials that I've seen. And so I've kind of dug into the program like a tick on a dog, and finding out some of these features to help us with our design issues and make things easier to use using the program. So with that, we're going to jump right in. We had a little project yesterday that I was working on, a friend of mine. He wanted a hard drive enclosure, and he wanted it to go horizontal across the top of his laptop, and he has 4 little portable Seagate drives. And so he wanted an enclosure for that. And so, okay, fine. So he measured the drives. He sent me the measurements, and we did the calculations, and we figured out how big it needed to be. And lo and behold, we discovered after we got it designed that he couldn't print it on his printer. So one of the considerations that you have to keep in mind when you're doing your designs is, how big is my design and how big can my printer print? Now, he says to me, well, if it's too big for the bed, can't we just tip it up on its end? And I said, well, in your case, no, because it's too tall for your printer as well. And so even though the printer bed, even though the printer height was able to be, it was an Ender 3, so he can print 250 millimeters up in the Z and only 235 on the bed. Well, 235 at the maximum. Ideally, 220, 225 square is what you're going to get on an Ender 3. And so maybe 230 if you're really lucky. And so he couldn't get there from here. So we had to redesign the project. So I'll show you what we ended up with. And let's see. I'm going to go ahead and I'm going to share my desktop, DesignSpark Mechanical. And so now you should see the DesignSpark Desktop with the shape, the final outcome. Actually, this isn't the final outcome. This is, excuse me, an interim design that we came up with. Eventually, we ended up punching some holes in the side, in each side. So this isn't the final. Now, this is what we came up with that he could print. So this way, he can just stand it up on end like this and print it on an Ender 3. It'll fit. Everything will be fine, and all of his drives will fit in here. Now, how did we get to here? Well, first we had another design that we did, and I'm going to go ahead and walk through how to do that design and show you how we got to this point, because it shows you some interesting features of DesignSpark Mechanical that most people might not be able to figure out, or it may not be all that intuitive. I mean, it wasn't intuitive for me, and but now I've been a developer for 40 years, not a drafting person. So if somebody who has drafting experience, they may realize that these things are so, but in my case, it's not. So I have to send a text here real quick. My wife just tried to call me. Let's see. All right, now she knows not to call me. Okay. So we're gonna go through the interim design that we created to get to this point, and then so when we ultimately end up where we're going to end up, well, it'll be here. Okay. So we're gonna go ahead and close this design, and we're gonna go ahead and start a new one. And that gives us our sketch plane. So everything starts with a sketch. I need a drink. Everything starts with a sketch. So now I have the measurements of the drive, and it's a little drive. It's a little drive. I don't know if I can show you. They probably won't like it if I unplug it, but it's just one of those little Seagate drive, little backup drive that you can plug into the laptop and back up your laptop or whatever. So I created another enclosure for, I got some drive enclosures off of eBay that fit 2.5-inch notebook drives. And so I have 3 of those, and I created this enclosure. Let's see here. Where is it? Created this enclosure for it that I can put a fan on the back and cool those drives. And so when Jim saw this, he wanted a similar enclosure for his drives. So that's where the idea came from. Okay, so we are going to draw a design, and DesignSpark is a parametric modeling tool, and that means it's more than just a drawing tool, more than just a drafting tool. It will actually evaluate simple expressions. Now, this is the second recording that I've made on this project. Well, that I attempted to make on this project, because the first one, I forgot to mash the record button. And so as a result, I went through this whole video and it hadn't recorded. So we're redoing it. But in the first instance, I found that my formula that I was going to try to show you didn't work the way that I had hoped. I had to do it the long way, because DesignSpark, even though it will evaluate some math, it's not all that smart. So you can't say, for example, we have 4 drives that we want to enclose. You can't say 4 times the width of the drive. It doesn't know how to do multiplication. It'll do addition, but it won't do multiplication. So I'm going to have to send a message to the folks at DesignSpark and say, hey, it'd be really nice if you could evaluate multiplication. It would make parametric modeling so much easier. And so we're going to start out by going to a sketch plane, and doesn't matter what axis we're on right now, because we're going to start from the top. So at this point, we know that we want to, draw a rectangle that is, we're going to enclose 4 drives straight across. So the drives themselves are 78.2 millimeters wide, and they are 20.8 millimeters tall. So we're going to round those up. So we're going to go to 78.5, and we're going to go to 21 millimeters tall. So we're going to just start out with a rectangle. We're going to go R on the keyboard and rectangle. And so now we have a place where we can put in our measurements. So in this case, we also wanted, so we have 21 millimeters tall, but we also want 4 millimeters top and bottom and 4 millimeters on each side for the walls. And in the middle of the enclosure, between each drive, we want a 2 millimeter or 3 millimeter divider. Okay, so we'll get to there. But in this case, we're going to say we want a rectangle that is 21 millimeters plus 4 plus 4 for the top and bottom. Okay, now we could have just said plus 8, but why not? So that's going to give us 29 millimeters tall. And now we're in the other entry field. And this is the one where it would be nice to be able to use multiplication, but we can't. So we have 4 drives. Each of those drives, we're going to round up to 78.5. So we got 78.5 plus 78.5 plus 78.5 plus 78.5. Okay, so that gives us our 4 drives, plus the 8 millimeters for the inside, for the left and right side walls, plus, and if we want 2 millimeter dividers, we're going to need 3 dividers. Then we're going to need an additional 6 millimeters. Okay, so 6 millimeters for the dividers. That's going to give us our rectangle of 328 millimeters. Okay, so now we're going to click off of here to terminate the rectangle, and we're going to zoom out here and pan over a little bit so you can see that we have a rectangle that is, oops, I don't want to do that. Did it again. I'm trying to pan. All right, so there's our rectangle using parametric formulas to calculate all of our dimensions. So we didn't have to break out a calculator and figure out that we needed 328 millimeters. DesignSpark says, okay, just put in dimensions that you need and I'll figure it out and give you the total. Now, it'd be real nice if I'd have said, give me 78.5 times 4. Boom. That would be really nice. So I'm going to have to talk to them about that. All right. So at this point, we're ready to draw our box, our 3-dimensional box that these drives are going to fit in. We're ready to go into the front to back design. So we're going to go into design mode, and we know that these drives are 114.8 deep front to back. So I'm going to round that up a little bit to 115, and then we need 4 millimeters for the back side of the box. So that's going to give us 119. So we're going to go up here to the pull tool, where we can do P on the keyboard, and we're going to highlight this face, and we're going to tip it up just a little bit so we can get some aspect on it. And then we're going to jump up here, and we're going to say 119, or we could say 115 rather, plus 4. Boom. So now we have our box is 119 tall. All right. So that gives us this is our enclosure outside dimensions. Now, another very little used, very little documented feature in DesignSpark is the shell command. Now, if we wanted to do this the hard way, we could simply select this face, go back to a sketch plane, and draw a rectangle. And like I said, this is the hard way. Now, what really makes this hard is we are zoomed out. And so all of these grid lines are approximations. These grid lines that you see here are not 1 millimeter grid lines. They're just a rough idea of the dimensions of the product. That's it. If we scroll in, then we get more accurate representations of 1 millimeter square. So if we go here, we would have to go in from here 4 millimeters, actually to here, but that's not quite 4. So it wouldn't quite be exact because it'd be 4 and a little more. Okay, so we're going to scroll out a little bit, and depending on where your cursor is, and you use your scroll wheel, it kind of changes focus. We're gonna pan over here. So now what we want is we're gonna go back into design mode. We're gonna do this the easy way. Now the easy way is to use the shell command. So there's a couple of things that you need to know about the shell command. First, you can create a shell inside of an object. And that means I can make this box hollow. To do that, and it's easy to do by mistake, so I'm going to show you how you make the mistake. So if you go over here to the project tree and you click on this, and now the box is solid, and you click on the shell, and you've got that selected like that, you notice that here in the middle, there's a little entry here that says 1 millimeter. By default, the shell function gives you 1 millimeter shell. Now, if I click on this green check mark right here and complete the shell, I have just created a hollow box. You can't do anything with this hollow box unless you figure out how to punch a hole in it. Well, we can punch a hole in it and we can get inside, but you have to punch a hole in it. So you'd have to go here to the face and punch a hole, draw a circle, draw a square, whatever, punch a hole. And it might be useful to have a hollow box, who knows? But this is how you create one. So what we want to do is we want to actually back out of this situation because we don't want, so we're going to do a Control Z for undo. And we're going to go back up here to this face. And we want 4 millimeters top and bottom, left and right, and the back. So right now we have 1 millimeter selected in the entry. So we're going to say 4, and then we're going to click on the face. And that's going to give us our shell of 4 millimeters on all the sides, including the back. So this back, front to back of the back, is 4 millimeters thick. Now, typically in DesignSpark, when you have a box like this, you've drawn the rectangles on the grid, and now let's say, for example, you decide that you needed a rectangle that was hollow all the way through. Normally, if you've drawn the rectangle using the sketch plane, you can take this back and you could just highlight it like that and push it out. Okay, so you go to the pool tool, go here. If you push this, it would go out the back and make a hole. But I'm going to show you, since we made this out of a shell, you can't do that. You can push it, but it's going to keep going back and keep going back because it knows that this particular object was created with a shell. So what we want to do is we're going to go ahead and back out of that. If you need to create, oops, we backed out of the shell completely. So go there and click that. All right. So now if you needed to punch out that back side, what you have to do is, come on. What you have to do is you'd have to spin this around, put a plane on the back, and then draw your 4 millimeter rectangle, 4 millimeter offset rectangle in here, and then you can punch out the back. Okay. The other thing that you can do is you can certainly draw a circle in back here. If you put a plane back here and you draw a circle, let's say you needed a hole for a cord to go through for some reason, or USB plug or whatever, you can certainly do that. Let's make a 10 millimeter circle. And so now if we go back into design mode, we can tip that up and we can push it through, and now we have a hole. All right. So that's how you get a hole in the back of the shell. Now, we'll go ahead and take that hole out. Yeah. That's funny that the undo actually undoes the entire shell. So we're going to get out of here. We're going to go ahead and go to the select mode. All right. Now, the next thing we need to do is we need dividers. So the easy way for dividers is we're going to go and we're going to put a plane on the back. We can do it on the front, but then we have to do some things afterwards to make this better. So we're going to put a plane on the back, and we're going to do the V to center it up. And then we're going to find the center of our box. Now, in DesignSpark, it actually tells you where the centers are pretty easily. In this case, like I said before, there's a little whirligig line here that looks like a BMW logo. That's the center of the project, front to back, left to right, front to top to bottom. And we can use that, okay? But in this case, what we're going to do is we're going to use this center to draw our dividers. So we're going to go up here, we're going to draw a rectangle. We need a divider that is 2 millimeters wide and 29 millimeters tall. So there's 2 millimeters, and we're going to say 29, and that's going to give us our center divider. Okay, so click on that, and that will complete that rectangle. Now, from here to here, we also have to find the center. And so how do we do that? We draw a construction line. And so in this case, we're going to zoom out a little bit until we can see the center of our line here. And we're going to select a selection line, a construction line, and we're going to go from here, or actually we can go from here to the end of there. All right. And that gives us a line of 159 millimeters long. Now, how does this line help us find the center? Well, if you zoom in a little bit and you hit that line, on that line, you're going to see a little pyramid pop up, a little triangle right about there. I can't put it on there because it will disappear. But if you go right there, that's the center, right about there, okay? So what we're going to do is we're going to use that line, and actually it falls in between two lines. So, see if we zoom in, there's the center right there, okay? So in this case, it could be interesting. So what we're going to do is we're going to draw another construction line. And we're going to draw another construction line from this center. You see that it puts a line up the screen, a little faint line. You might not be able to see it on the video, but we're just going to go up to there. So that's another construction line. All right. Now from here, we can draw our box. So we're going to start a rectangle. This could be interesting because we're right in the middle of a couple of lines. Let's do this. Let's draw one that's 3 millimeters wide, like so. and then we'll resize it. So, and actually we want to start up above. So we want to go up here at the top, 3 millimeters. So we want a rectangle 3 millimeters wide by 29 millimeters. Oops. 3 by 29. All right, so that gives us our rectangle. Now we know that 3 millimeters is too wide. It's too wide by a millimeter, a half a millimeter on each side. So what we're going to do is we're going to adjust that. What did it do to us? Did it not complete the rectangle yet? No, it didn't. Okay, we hadn't completed it. So let's do this and go back here and go back here. Do the rectangle. 3 by 29. Yes, I hadn't hit enter or clicked off of it. All right, so now we have our rectangle that we need. Now, we just need to remember that we need to close that rectangle in by half a millimeter on each side. Now we're going to go back over here to the other side and do the same thing. So in order to do that, we're going to grab this line and we're going to hit the select tool and we're just going to move this line over. So we're going to come over here to the other side where we can see. We're going to grab this line and we're just going to select it. Oops. See, will it not let us move it? There it goes. We're going to select it and we're going to move it over here. Maybe we need to select it over here, further over, so we can have some room to move. And we're going to put this line, the end of this line right here on the inside of that divider. And now that line will go all the way out to the end here where it needs to be. So now we can find the middle section of this point. And once again, it's going to be in the middle between two squares. And so we just need to adjust that accordingly. So we're going to draw a construction line. Actually, we could just drag the other construction line over. No sense in drawing a new line if we can just grab this one and scoot it over to the middle of this other construction line. So just go there and we'll deal with, we got to find the middle of this line, which is right there. Oh, too far. I believe it's going to be right there. Yeah. All right. So now we're on the middle of the construction line. And now from here, this is where we need to draw our rectangle for the other divider. So we're going to go from this construction line, we're going to go out to here. We're going to draw a box 3 millimeters and by 29. So there's 3 by 29. Complete the rectangle, hit exit. Now we can get rid of those construction lines. We don't need them. Right click, delete. Right click, delete. And so now we have three dividers, and we're ready to go to the next step. So the next step is we hit the D key, and that gives us our sections that we can pull out. So now what we're going to do is we're going to highlight each one of these sections. Going to click it, hold the control key, click it, hold the control key, click it, hold the control key. We're in the pull mode, so we can pull out. And if we just click the up to button right here, up to this face, that's going to pull all of those up to that face and make our dividers. Okay, so now what you see though, we have this divider here is 2 millimeters, and these are 3. So we need to go in on each of these by 0.5 millimeter. And so there is a way to do multiple faces in DesignSpark. If you click on that one and then turn it over here and click on that one, if you go in using, I believe it's this little box down here, pull both sides, it will do both sides of that divider. Now let's just see if that's the case, because we should see it. You see that it's moving in there? Okay, so we only need 0.5 on each side. So we're going to go 0.5 millimeters. And that's going to give us our 2 millimeter. If we go here and we go here, if we click on the measuring tool, you can see down here we have 2 millimeters wide now. Okay, so we can do the same thing for the other side. We'll go here and we'll go here. Whoops, I didn't hit the control key. And then I'm going to scoot over here so we can see what's going on. Go back here to the pull mode, and we're going to go in on both walls 0.5. So that's going to trim, and I don't think it did that because for some reason. There. Let's see how much, see what the distance is here. Hold down the control key. Right now, all right, so right now we have 4 millimeters, but what we need is 2 millimeters. So it must have went out. So we're going to go here, and we're going to go here. I missed the control key again. All right, so now if we go in with the pull tool by 1 millimeter, that's going to give us our 2 millimeter divider. Okay, so now we have our enclosure with that's going to hold all 4 of our drives across the side horizontally, and we have dividers at the places that we need to go. Now let's just verify that our drives are going to fit in these locations. So the easiest way to do that is we go here to the edge of the back, and we click on the measurement tool, and it says 78.5. Okay, so that's what we want. We have our drives are 78.2 and 78.5. It should fit. It should be a little snug, but it'll fit. And so we're gonna just check this one, and this one here is 78.5. And then this one is 78.5, and this one is 78.5. So everything is identical, okay? And then to check the top to bottom, just for the heck of it, we have 21. So everything is fine. At this point, let's say you're fine with this. This is the way you want your enclosure to look. You're done. Now I'm going to show you, using the project command, how to do something really cool. Now, it matters which face you use to do your project. Now, let me explain. The first thing we're going to do is we're going to punch some holes. So we're going to go back over here and we're going to get a plane, and we are going to punch some holes in this design. So we're going to go here, we're going to say circle, and we're going to go here to the center, and we're going to draw a 8mm circle. And then we're going to go here to the center between those two circles, between that circle and the edge, and we're going to draw another 8mm circle. Now you notice when I get to 8mm, let me stretch out just a little bit. So there's 10mm. If you look at the middle circle that we drew, it's black. But when I hit 8mm, that circle turns green, and that tells me that the circle that I'm drawing is the same size as the circle that I have already drawn. So we can just go there, and then we go back over here, and we can draw another circle, 8mm, and you see both of the other circles that I previously drawn are green when I get to the same size. So then I can just release it and get out of there and hit escape. Now I have 3 circles. I'm ready to do 3 holes. Go into the design mode, hit the D. I can either do one of these one at a time, or I can highlight, hold the control, highlight, hold the control, highlight. And now, using the pull tool, I can push those through, and now they are holes in the side, as you can see. Now, I can easily do that on the other end. That's not a problem. I mean, it's not hard to do, but why do it hard if you can do it easy? And the functionality that makes this easy in DesignSpark is the project function. Now, like I started to say, it does matter what side you use to project. And here's why. If we do these circles, and we use this face to do the project to this face, then our projection is exactly like the other face. We don't have to do anything afterwards. But if we decide we wanted to do the projection of, let me just move this over here so we can see, this face, which gives us the same 3 circles in the same positions, we can project this face onto this face. But when we do, we will get a line outlining the inside dimensions of that face. And then we have to clean it up. So just be aware, if you're going to project something and there's differences in the face, inside and outside, just make sure you pick the face that you really want. Otherwise, you just create some more work for yourself. So in this case, we are going to, we're going to project this other face right here. So we're going to highlight it, and we're going to say project. Now it says, select the face, surface, edge, or note text to project its edges perpendicularly to the other face. Now, we have a face. We've got it. That's selected. The project feature knows that that's the face we want. Now we have to select the target face. Now, we could, if we wanted to punch these holes through these dividers, we could have easily just pushed them all the way through these dividers, but we didn't want to put holes in the dividers, okay? But what we want to do is we want to project the holes onto this face. So we're going to say, select the target face, go here, and now what we have is, let me zoom out a little bit. We have this projection on the face, okay, of where the 3 holes are. So now if we just hit the check mark, now we have, just like we had drawn a sketch, we have our 3 holes, and then we can hit the hit one, hold the control, hit another one, hold the control, hit another one, go to the pull tool, and push those through. Now we have 3 holes in exactly the same place as the other 3 holes. So it just makes The project feature just makes things a lot easier. Now, the interesting thing is that the projection doesn't affect any of these faces. You said send this face to this face, and it doesn't do anything to these others. We could have done it. We could have projected on all of these faces, and then we would have had to do a lot more work punching holes. So those kinds of things are just really cool to do. At this point, of course, we're done with this design. We can go ahead and save it. And let's see, we want to say save, and we're going to say Seagate backup plus horizontal with holes. All right. Now, you saw in the other model where we had 2 on 2 stacked up, one on top of the other. How did we get there? Well, we already had this model drawn. And so we said, rather than just start from scratch and redesign the model, why do that? That's ridiculous. That's a lot more work, okay? I said, let's use this to split. Let's use this, another function that's very little documented or very little shown, and split the body of this object. And let's see what we got here. I got surface. What is that surface? That, oh, okay, we can kill those. That's drawing, delete. And then we have curves. That's going to be probably some construction lines. Yep. All right. And we can get rid of those. All right. So now we have just a solid body of our object. Okay. And so we need to take this half of the body and move it under this half of the body. Okay, we can do that. It's actually pretty easy, but there's a trick. So the first thing that we have to do is we have to split this object. So we're going to say split, and it says select a face or edge, and then select another object to split it with. Or we can split body, click a target object, this guy, and then click a face, plane, or edge to use as a cutter. So in this case, we want to split this object using this face. Now, if you hover over it, you'll see that there's a little plane there. We could pick that one. We pick that one, and there's a little plane, and on the cursor there is a little saw. So if you click that, it's going to cut it right there, and then we can go ahead and get back out of the split mode by clicking on select. Now, so now what you see here is you have a line. There's one object. Here's the other object. Okay. Now, the question becomes, how do we move these objects and align them? Now, aligning things in DesignSpark isn't exactly intuitive. There's no alignment like we would normally have. Like, for example, in 123D design, if you select two objects and you have them selected, there's an alignment function where you can align them by center, or you can align the edges, and it's fairly easy to use. DesignSpark's not that intuitive, okay? But you can do it. You just have to know how. So in this case, what we're going to do is we're going to align the edges with the move tool. So we're going to select our object. So we have two objects now, solid and solid one. So we're going to rename these. And we're going to rename top half, hit enter, and then we're going to rename this one and be careful not to hit delete when you do that. Rename to bottom half. That way we can keep them straight. We know which is which. So there's the top half, there's the bottom half. All right. Now, how do we put one on top of the other? The first thing that we have to do is we want to align certain edges so we don't have to do more work later. Okay? So first, we have to select the bottom half. Let's say select the top half. We'll move the top half. And let's see, is it easier to move the top half? Because I want to do as little work as possible. Excuse me. The object here is to work harder, not smart. Work smarter, not harder. And so if we move the top half, then we have to create this edge, this wall. If we move the bottom half, it'll be easier to recreate this wall. And I'll show you why. So we're going to move the bottom half down. And we're going to move the bottom half down a certain way so we don't have to do nearly as much work. So we've got the bottom half selected. We're going to select the move tool, and that's going to give us our move item, object, thing that we use to move tool. And you're going to notice right here, there's a little yellow ball or square, and you can move it around. So in this case, we want to align this edge here with this edge here. Now, the reason we want to do that is because we want this face to this bottom face to overlap that top face. That way we don't have something that's 8 millimeters too tall on the front. Okay, so what we're gonna do is we're gonna go there, and we are also going to go to this edge right here. And there's a reason for that. So now, let's see, we want this edge and that edge. All right. So at this point, we're going to move this let's see, we want that edge right there. So at this point, we're going to move this whole object. So we're going to do this in 2 steps. So we're going to click that arrow, and that puts us into a special mode, so it will constrain it to only move up. So we're only going to move up, and we're going to move up to this face right here. It's real important. Use up to. It's real easy. So now we have it moved up to that face. Okay? And then we're going to get the move, and we're going to move this to that corner, and then we're going to pivot this around a little bit, and we're going to hit this arrow, and that's going to put it, constrain it so it can only move horizontally. And once again, we're going to say move it up to that face. Oops. And it says it couldn't be moved. Why? Is it in the way? Is it might be in the way. Okay. Let's move this up just a hair. And to do this, we're going to have to select it. Bottom half. We're going to select the whole thing. And maybe that's what the issue was. We weren't selected right. So let's go back down here, and we're going to select that edge right there. And we're going to select that arrow right there. And we're going to select the up to and select here. There we go. That's what we want. Now, is that what we want? It's moved it to the inside edge. No, we don't want that. We want to move it to up to this face. So that gets us what we want. Now, I'm going to do a little bit of cleanup, not bad. So now, let's see. Let's do as little as possible. We're going to go back here. We're going to take this edge. We're going to put it here. And we're going to click this, and we're going to say move it up to this face. There we go. So now we have those faces aligned. And we have something we can use here to clean up this end. So in this case, the first thing we want to do is we want to address the thickness of this wall, because this used to be the divider, and this wall. So the first thing we're going to do is we're going to go back here to the pull tool. We're going to highlight this face. We're going to say up to this side. So now we have both of those faces are the same. And then you notice we have some cleanup to do here. And so there's a couple of different ways we can do this. Let's think about what's the easiest way. So the easiest way is we need to bring this edge out. So what we can do is we can extrude just the edge. Okay, if you think about this, some people would say, oh no, just drag this out, and then you have to, if you do that, then you have to clear up this, and then what you'd have to do is draw a line in here on a plane, and then extrude up. But if you do this way, it's real easy. If you just extrude this edge right here, so you click on this edge, and there's a function here that says extrude edge. It's right there in the little flyout menu. It's also down here on this menu. So we say extrude edge, and that's going to change our cursor. So we can extrude the edge out this way, or we can extrude the edge front to back. And that's the one we're going to do. So we're going to grab that arrow, and we're going to go this way, and we're going to go out to here, and then we're going to say up to, up to this face. So that gives us the edge that we need to clean up this particular situation. Okay, so now we can say, highlight that one up to this face. Highlight that one up to this face. And then we can turn it around, excuse me. And we can say, highlight that one up to this face. So now you can see we have all of our faces, and then we have this one up to this face. We didn't have to do any sketches. We didn't have to do anything, just a few clicks and we're done. And now we have an enclosure that, oh, you know what we have to do? We have to move the divider because the dividers aren't right. We lost some space on one of these lines. So which one is it? So that one is 76.5. So we lost 2 millimeters there. So we have to move that top divider to match this one. Okay? Because this one here is 78.5. So what we do is real easy. We highlight this face here say up to this face here, and then we say this face here up to this face here. Now we're even. We're done. And then, well, we're done unless we want holes. So we can say, all right, let's put these holes on this end and these holes on this end. So we say, okay, project. Now see, we don't want to do this because if we do this, it's going to put these holes on this end on the bottom, and it's going to wipe out these holes on the top. Okay. So, well, maybe not. Let's try it. So we're going to say there, project that face onto this side, or this face onto that side. We'll just go ahead and choose a target. So now we have our holes, but you see, let's just see what happens. There's that one. Okay, so it didn't close them up. It just projected them, and it didn't close up the bottom holes. That's good. That's fine. Did it put solids in there? Let's see. No, it didn't. Okay, awesome. So that works. And so then we're going to say project this face onto this face. So we're going to say select the target here. Oops. Select the target and then the check mark. All right. So now we have the holes that we need. Now we have the places that we need. And let's see if we can do this. We're going to highlight those, and we're going to highlight those. And let's see if we can make it operate on two directions at the same time. So we're going to go here to the pull tool, and we're going to push these holes in. Oh, the pull tool is not active. Boom, boom, boom. Scoot this around. Boom, boom, boom. So now do we have everybody highlighted? No. Hold down the control key. What's going on? Control, control, control. Control, control, control. So now we have everybody highlighted, and go back here to the pull mode. And then let's see, will it push? No, it won't. Interesting. You see what's happening? It's moving the inside of the walls. Don't know why. Ah, it did what I thought it would do. It created a problem is what it did. So let's go here. So we've got that. We have to do one side at a time. Go pull, punch them through. And then project this face to the target, this face, and then we can boom, boom, and hit the pull tool and push those through. Now we have our holes. Interesting that that the projection actually created a phantom wall, which is why this side here started changing when we started pushing this circle. So because apparently it created a phantom face. Can we select it? Let's see. No, but it's there. We saw the effects of it. So now we have our enclosure with all the holes. Everything's evened up, and you saw some really cool stuff about aligning issues and just working a little smarter. Just think through your design process, and you'll be fine. So let's go ahead and stop the share. I'm going to go ahead and save this out rather. And let's see. That's horizontal with holes. And so let's go save as. And we're gonna change this name to stacked. All right, and then we, of course, I always automatically export the STL file because who knows, I might want to print it. All right. So now, after all, I am the 3D printing technician, so I got printers to feed. Now, that gives us our enclosure. Everything was fine. All the drives will fit in it. You saw how to even things up. But most importantly, what I want you to take from this is, and I'm going to go ahead and stop my share. Most importantly, what I want you to take from this is how to work smarter in your design. Now, I'm not an expert, but like I said, I was a software developer for more than 40 years, so I learned how to think logically. And sometimes you just need to sit down and sit back and think about how to do something with as least amount of work as you can possibly do. It's not that you're lazy, but you're just being smart and efficient with your time. Okay? So that concludes our tutorial on parametric modeling in DesignSpark, the shell tool in DesignSpark, and let's see, what else did we cover? Parametric modeling, shell, and using the move tool to align objects. Okay, so those three things are important things to take away, and play with the tool, play with DesignSpark. It's a very good program. It's a lot easier to use than Fusion 360, in my opinion. Not that my opinion counts for a whole lot, but I find it easier. Now, the big reason that I use DesignSpark is this. We live in the sticks here in Texas. We are 12 miles from everything. If I want a hamburger at Whataburger, which is my favorite hamburger, I have to drive 12 miles in any direction. I can go 12 miles to Lockhart, 12 miles to Kyle, 12 miles to San Marcos. If I want to go to Austin, that's another 15 miles to the Whataburger there. But if we want to go grocery shopping, we're 12 miles from everything. There's nothing here. And that means we don't have broadband internet either. And so how we get our internet is through the cell phone provider that we use, AT&T. And I'm not plugging them in it. I'm already ticked off at them enough. But at the same time, Fusion 360, although it's a great program, and I have a subscription to it, I use it. I've tried using it. The problem with Fusion 360 is this: it requires a broadband internet connection so you can send stuff up to their cloud. You can probably save to the local machine, but you can't use the product effectively without being connected. And so because of that, and because our internet connection is via the cell phone signal, and it's a metered signal, I have to pay for broadband, for a bandwidth. Then it really gets to be problematic if you're having to run something that's connected online all the time in the cloud. DesignSpark doesn't require a connection. Everything is done locally in your machine. You don't have to worry about it. The only thing that every now and then you'll hit like the start page, and the start page goes out to the internet to bring in content. But that's a far cry from using Fusion 360 with this kind of connection. So that's the big reason I use DesignSpark. And as I got to using DesignSpark, it's really a good tool, and it's really geared toward 3D printing. For example, I'll give you a taste of another little functionality. Let me go back here to the share so I can show you. So we have our model, and we decide that we want to print it. We can save it out as an STL file. That's fine. That's great. Awesome. Or we can say, go up here to the export options button And you see right here, they have an interface with Cura, the slicing program. So if we click on this button, it's going to take this model and it's going to send it to Cura. And if I go up here to my share, or actually I'll just go ahead and, yeah, I have to do it this way. So I'll go back up here to the share and I'll wait for Cura to come up. And go here and share that window. And now you see that our object is in Cura. Now it says that it's an invalid file, and that's because there's a problem with the name of the file and the location where I have it, that it sends its temporary files. But you can see that the model itself is here on the platform, and you can do, you know, whatever you need to do. There's the back, there's the front, and in this case, what we would want to do is we would want to select it and rotate it 90 degrees and print it like that. And now at this point, you can just send this to the printer. Boom, you're done. No monkeying with saving the STL file and then opening it up Cura, pulling the STL file in. You just sent one click from DesignSpark over to Cura, and that's great. It's got a little glitches, but it works. So that's really cool. All right, so let me stop the share here. So just another little feature in DesignSpark that makes it easier. DesignSpark really is geared to be a 3D modeling tool for people that have 3D printers. It just doesn't get enough exposure. So that's going to close it out for me. I'm going to go ahead and stop the recording. And I want to tell you, have a great afternoon. Enjoy yourself. Get out in the sunshine. Don't sit in front of the computer designing stuff all day like I do. I am Ben Brady, the 3D Printing Technician. Have a great day.